Okay, so, we all rely on critical applications these days, right? I mean, all the time, often without even realizing it. But have you ever actually stopped to think what would happen if those systems suddenly just disappeared?
It's kind of a scary thought, isn't it?
It really is. And that's exactly what we're diving into today. How do organizations actually prepare for the unthinkable? A true disaster that could completely cripple their most vital applications.
We've got some really interesting material to dig through here, a sort of blueprint for navigating the chaos when it hits. And the best part, it's not just theoretical. We're talking about real-world strategies that are keeping things running when, well, everything seems to be falling apart.
And for you listening, our mission is to cut through all the noise and give you the core of this knowledge. A clear understanding of what goes into building a rock-solid disaster recovery strategy. And don't worry, we'll do our best to keep it jargon-free. Get ready for some surprising insights and some really, really practical takeaways.
Sounds good to me.
All right, so this material starts by laying some groundwork. Understanding the risks, what's at stake, setting the stage.
And what's really fascinating is this initial phase risk assessment. It's like, imagine a detective trying to figure out all the different ways a crime could happen.
Yeah, trying to stay one step ahead.
Exactly. Here, it's about identifying every single potential threat that could disrupt those critical applications. The material lays out a whole range of culprits. We've got the usual suspects like natural disasters, floods, earthquakes, those kinds of things. Then there's the constant worry of hardware failures and the ever-evolving world of cyber attacks.
It's almost like you can never fully relax.
Right.
Always something lurking around the corner.
It's true. And then there's the human element, too. Simple human errors, which, let's face it, we're all prone to. And even wider infrastructure problems like power outages or network failures.
Right, so it's not just about brainstorming every bad thing that could possibly happen. It's about going deeper.
Right. Absolutely. For each potential threat, you need to consider two key things. How likely is it to actually occur? And what would be the impact if it did?
Getting a sense of the magnitude.
Exactly. This allows organizations to really focus their resources on the risks that pose the biggest danger. A company in a hurricane-prone area is going to have a different set of priorities than a company in, say, a seismically stable region.
It's all about context.
Exactly.
Now, this naturally leads us to the business impact analysis, or BIA.
The BIA.
For those who might not be familiar, what exactly does a BIA help an organization figure out?
Well, the BIA is all about understanding the real-world consequences of a disruption, the actual pain points. Think of it as calculating the cost of a shutdown.
Putting a dollar amount on the chaos.
In a way, yes. It pinpoints the critical business functions that absolutely rely on these applications, maps out all their dependencies, basically what else needs to be working for them to function, and then ultimately determines which of those functions need to be recovered first and how quickly.
So it's almost like a triage situation. Figuring out what needs immediate attention.
That's a good analogy. And what's really interesting is that modern BIAs are even incorporating something called failure mode and effects analysis, or FMEA.
FMEA. That sounds pretty technical. What's that all about?
Okay, so imagine an engineer stress testing a bridge design in a computer simulation, right? They're trying to find the weak points before it's even built.
Avoiding a catastrophe down the line.
Exactly. FMEA is similar. It's a systematic way to examine an application's architecture and proactively identify potential points of failure, like what are all the individual components that could break. And then critically, it analyzes the ripple effects of each of those failures.
So you can see how one problem could snowball into something much bigger.
Exactly. This helps in building more resilient systems right from the start.
So whether you're a massive global enterprise, worrying about a huge outage, or even just thinking about the apps you rely on personally, understanding where things could go wrong and the domino effect seems like a fundamental first step.
I couldn't agree more.
So once you've got a good grasp of the risks and their potential impact, the next logical step is to define your recovery targets. The material introduces two really key metrics here: recovery time objective, or RTO, and recovery point objective, or RPO. And these are absolutely crucial.
You got it.
RTO and RPO. They sound a bit like something out of a sci-fi movie,
Okay.
but they're really the nuts and bolts of disaster recovery, aren't they? So let's start with RTO, What exactly does that tell us?
Okay, so RTO, or recovery time objective, is the maximum amount of time a critical application can be down before it starts to seriously hurt the business. And the material highlights that for truly mission-critical applications, this could range from near zero downtime, like we're talking almost instantaneous recovery,
Wow.
to maybe a few hours at most. Think of something like an emergency room system,
We
right?
can't have that down for long.
Absolutely not. Its RTO would have to be incredibly tight.
So if an online retailer has an RTO of, say, 1 hour, that means they're aiming to have their website back up and running, taking orders within 1 hour of an outage.
You got it. And every minute beyond that, they're potentially losing serious money.
The clock is ticking. Now, RPO, or Recovery Point Objective, that's all about data. What does the term point make you think of in this context?
That's a good question.
Yeah,
It makes me think of a specific moment in time, like a snapshot.
you're exactly right. RPO defines the maximum acceptable data loss that an organization is willing to tolerate, and it's measured in time. So an RPO of 15 minutes means that in a worst-case disaster scenario, they're willing to potentially lose up to 15 minutes worth of data transactions.
This could be measured in seconds, minutes, or hours, depending on how critical that data is.
No.
Imagine a stock trading platform, right?
High stakes.
Its RPO would likely be measured in seconds, maybe even milliseconds.
Wow, that makes perfect sense. A financial institution dealing with millions of transactions per second is going to have a much, much lower tolerance for data loss than, say, a company that updates its internal policy documents once a week.
Absolutely. And the material really emphasizes that these objectives, RTO and RPO, they're not just arbitrary numbers someone pulls out of a hat. They have to be directly tied to the actual needs of the business.
What level of disruption can they realistically handle?
Exactly. And often, these objectives are formally documented in something called service level agreements, or SLAs.
So these RTO and RPO targets, they really become the guiding principles for the entire disaster recovery plan. They dictate the specific technologies that are chosen, the level of financial investment required.
Absolutely.
It makes you really stop and think. How different would a recovery plan look if you absolutely could not afford any downtime or data loss compared to a situation where you could withstand a few hours? The cost implications alone would be enormous.
You're right. It's a huge factor.
So once you've got those recovery objectives nailed down, the next big piece of the puzzle is designing the actual disaster recovery architecture. And material outlines a few common standby options, each offering a different balance between recovery speed and cost.
A menu of options.
Exactly. Let's walk through them. So the first one is hot standby. That sounds like it's ready to jump into action at a moment's notice.
Oh, it absolutely is. A hot standby involves maintaining a fully operational, mirrored secondary environment, and it's constantly running in parallel with your primary system.
Like a shadow system.
Exactly. Data is continuously replicated in real time, so if the primary system fails, that secondary system can take over almost instantly, often without any noticeable interruption. This is the gold standard for those near-zero RTO and RPO requirements we just talked about.
So virtually no downtime, minimal to no data loss. That sounds pretty good. What's the catch?
Well, as you might imagine, the main trade-off is cost. Maintaining a completely redundant, always-on environment requires a significant investment. We're talking hardware, software, and ongoing operational expenses. It can add up quickly.
Makes sense. Okay, next up we have warm standby. What kind of setup are we talking about here?
Warm standby is kind of like a step down in terms of immediate readiness, but also in cost. So the core infrastructure is in place, and it's running at the secondary location, but it might need some configuration, some software startup procedures, maybe a final data synchronization before it can fully take over.
So it's not quite as instant.
Exactly, but it's a good middle ground for applications that are critical but can tolerate a slightly longer recovery window.
Okay, so you'll experience some downtime, but it won't be as long as with the next option, which is cold standby.
Cold standby.
That sounds like it's barely even turned on.
Yeah, that's a good way to think about it. With cold standby, the essential infrastructure, like the physical hardware, might be in place at a secondary site, but it's largely idle. Recovering from a cold standby scenario requires a much more involved process. Installing software, restoring data from backups, configuring the environment. It's the most budget-friendly option for sure, but it's really only suitable for applications that can withstand more significant periods of downtime.
So it depends on what you can afford to lose and for how long.
Absolutely.
Now, the material also briefly touches on hybrid approaches. It sounds like that's about combining elements of these different strategies.
Got it. Organizations might strategically choose to implement a hot standby
Hmm.
for their absolutely mission-critical applications, the ones that cannot tolerate any downtime whatsoever.
Right.
Then maybe a warm standby for moderately critical systems, and perhaps even a cold standby for less essential data or applications, all within a single comprehensive disaster recovery plan.
It's about tailoring the solution to the specific needs. And it's really fascinating to see how modern cloud-native applications are changing this landscape. They're using multi-region deployments
Yeah.
and automated failover capabilities.
Oh, absolutely.
For those familiar with cloud services, the idea of an application seamlessly shifting its operations to a completely different geographical region if there's a problem.
Like magic.
It's a game changer in terms of resilience.
It really is. It shows how technology is evolving to build disaster recovery directly into the fundamental architecture of applications.
Baked right in.
Now, regardless of the specific architectural approach, the material really hammers home that a strong data protection strategy is absolutely essential to any effective disaster recovery plan.
Data, the crown jewels,
Yeah.
often the most valuable asset an organization has. So what are the key components of safeguarding that information?
Well, the material details several important backup mechanisms. This includes the fundamental types of backups, full backups, which capture every single bit of data. Then there are incremental backups, which only capture the changes made since the last backup. And then differential backups, which capture all the changes since the last full backup.
So you've got options depending on how much data you're dealing with and how often it changes.
Exactly. And importantly, it also emphasizes the need for clearly defined data retention policies. How long do you need to keep those backups to meet your business and regulatory requirements?
Right. You don't want to be hoarding every single backup from the beginning of time.
That would be a bit much.
Now, what about keeping the data more actively synchronized? That's where data replication comes in, right?
Absolutely. The material outlines two primary methods of data replication. Synchronous replication aims for zero data loss. How do you think they achieve that?
Well, if it's about keeping things in sync, I'm guessing it's about making sure every change is reflected in both the primary and the backup location simultaneously.
You got it. It's like writing in two identical notebooks at the exact same time. That's synchronous replication. However, this can introduce some latency, especially when the secondary location is geographically distant.
The information has to travel farther.
Exactly. Asynchronous replication, on the other hand, allows for greater distances between those primary and secondary sites. But there's a trade-off. It introduces a small window of potential data loss because the data isn't written to both locations at the exact same instant. It's more like writing in one notebook and then copying those pages to the other a little bit later.
So there's a slight delay.
Exactly.
It's a balancing act between absolute data consistency and the flexibility of having those sites far apart.
Exactly. Now, the material also delves into some database-specific considerations because databases are often the heart of these critical applications.
The brains of the operation.
You got it. And different database management systems offer their own built-in or add-on features designed for high availability and disaster recovery.
So they have their own built-in safety nets.
In a way, yes. The material gives some examples like database mirroring and always-on availability groups for SQL Server. It also highlights the advantages of using managed database services in the cloud, which often have robust replication and automated failover capabilities built right in.
So it's almost like outsourcing some of the risk.
In a sense, yes.
Now, it's not just about the database software itself. It's also about the underlying storage infrastructure, right?
Absolutely. Storage-level replication, using technologies embedded in storage arrays or provided by software-defined storage solutions, offers block-level protection of data.
Block.
This means that it's replicating the data at a very low level, copying the individual blocks of data that make up your files and databases. And this can be a very efficient way to replicate entire volumes of data between sites, providing a foundational layer of data protection.
So you're replicating everything down to the smallest bits.
Exactly.
Okay, so we've covered the overall architecture and how the data is protected. But how does the network infrastructure fit into all of this? You could have perfect backups sitting on a secondary site, but if you can't actually access them...
It's all for nothing.
Right. It's like having a spare tire in your trunk, but no jack to change it.
That's a great analogy. So the network architecture is really the nervous system of disaster recovery. It's what connects everything. And the material highlights several vital components, starting with something called DNS failover mechanisms.
DNS failover.
These are like the internet switchboard operators. They make sure that user traffic is automatically redirected from the failed primary site to the operational secondary site.
Like a traffic controller instantly rerouting cars if there's an accident on the highway.
Exactly. Then there are load balancer configurations. These need to be carefully designed to handle disaster scenarios, ensuring that incoming traffic is distributed intelligently across all the available servers in that recovery environment.
Spreading the load.
Exactly. Then there's the often underestimated aspect of network capacity planning. You need to make sure your secondary network infrastructure has enough bandwidth to handle the full load of user traffic if that primary site goes down. And finally, you need secure and reliable connections between those primary and disaster recovery sites. Things like secure VPNs or dedicated direct connect solutions, those are essential for secure data transfer and ongoing management.
So you need a rock-solid connection.
Absolutely.
It really sounds like building a parallel infrastructure that's ready to step in seamlessly. Now, the material also mentions something called infrastructure automation, using tools like Terraform or CloudFormation.
Oh yeah, that's a really modern approach.
What's that all about?
So, infrastructure as code, or IAC, lets you define and manage your entire infrastructure, servers, networks, storage, all using code.
It's like programming your infrastructure.
Exactly. And this means you can provision your disaster recovery environment in an automated and repeatable way, guaranteeing consistency with your primary setup and significantly reducing the risk of manual errors during setup or failover.
So it's about taking the human element out of the equation as much as possible.
As much as possible, yeah. This can dramatically improve both the speed and reliability of your recovery efforts.
So automation is a key theme here, and it keeps coming up. The material goes on to discuss automation and orchestration specifically in the context of disaster recovery.
It's essential. Modern disaster recovery plans rely heavily on automation to boost speed, improve reliability, and minimize the potential for human error, especially during a high-pressure crisis.
Because when things are going wrong, you don't want to be relying on manual processes.
Exactly. The material gives some great examples. Automated failure detection, using sophisticated monitoring systems, can actually trigger the recovery process automatically without any human intervention.
Wow, so the system can basically heal itself.
In a way, yes. And then there are orchestrated failover procedures. These are often managed by specialized tools like Azure Site Recovery or AWS Elastic Disaster Recovery, and they automate the entire complex sequence of steps involved in switching over to that secondary environment.
So it's not just about reacting to a disaster, it's about having these pre-programmed and tested sequences of actions ready to execute.
You got it. And even the traditional concept of runbooks, those step-by-step manuals for recovery, they're evolving. They're increasingly implemented as executable workflows, essentially scripts that can automate many of the recovery tasks.
So they're no longer just static documents.
Exactly. And even CI/CD pipelines, which are typically used for software development and deployment, can play a role here. They ensure that applications are deployed consistently across both the primary and secondary environments.
So it's all interconnected.
Exactly. This really highlights the increasing sophistication of modern disaster recovery strategies.
Now, all this detailed planning and sophisticated automation sounds fantastic on paper, but how do you actually know if it's all going to work when a real disaster strikes?
Well, that's the million-dollar question, right?
It is, and that's where rigorous testing comes in. The material really emphasizes the importance of a comprehensive testing methodology.
It can't be stressed enough. Testing is the ultimate validation point for any disaster recovery plan. The material outlines a whole progression of different testing methods, each increasing in complexity and realism.
Levels of testing.
Exactly. It starts with tabletop exercises, which are basically structured walkthroughs of various disaster scenarios.
Like a fire drill for your IT team.
That's a great way to put it. And this involves all the key stakeholders.
So everyone knows their role.
From there, you move on to component testing, where you individually validate the recovery procedures for specific systems or components. And then functional recovery testing takes it a step further. It ensures that the actual applications function correctly in that recovery environment.
So you're making sure things actually work as they they should.
Exactly. And then you have the most comprehensive form of testing, full-scale
At a
simulations.
scale. That sounds intense.
It can be. Full-scale simulations involve actually executing a complete failover to the disaster recovery environment. You're mimicking a real disaster scenario as closely as possible.
The whole shebang.
This is the most thorough way to validate the effectiveness of your plan. From data recovery to application functionality to user access, everything.
Leaving no stone unturned.
The material also introduces a really interesting concept called chaos engineering.
Chaos engineering. That sounds a bit, well, chaotic.
It does, doesn't it? But the idea is to proactively introduce controlled failures into your systems in a production-like environment. It helps identify hidden weaknesses and build greater resilience.
So you're intentionally breaking things to see how the system reacts.
In a very controlled way, yes. It's all about learning how your systems behave under stress by intentionally causing problems. Now, regardless of the specific testing method, the material stresses the critical need for establishing clear success criteria for each test, meticulously documenting the results, and then using those findings to continuously refine and improve the disaster recovery plan. It's an ongoing process.
It really makes you think about the different levels of confidence each type of testing provides. A tabletop exercise might reveal communication breakdowns, whereas a full-scale simulation would expose actual technical limitations.
Absolutely.
Now, all this crucial information, the risk assessments, the recovery objectives, the architecture diagrams, the testing results, it all needs to be carefully documented, right? And the material details all those essential documentation requirements.
Oh, documentation is paramount. It's the blueprint for recovery when a crisis hits. And the material lists several key components that should be included, starting with detailed infrastructure diagrams, including a clear map of your network topology. It's like a visual guide.
Like an emergency evacuation plan for a building.
Perfect analogy. You also need to thoroughly document system dependencies and service mappings so you understand exactly how different components rely on each other. Step-by-step recovery procedures, ideally incorporating decision trees to handle various potential scenarios, are absolutely critical. And don't overlook basic but vital information like up-to-date contact details for all the stakeholders and vendors, clearly defined escalation paths, and even pre-approved communication templates for keeping everyone informed during an event.
So you're prepared for every scenario.
As much as possible. And the material also reminds us of regulatory compliance requirements. You need to document evidence of your recovery capabilities for auditors.
So it's not just about having a plan, it's about proving you have a plan.
Exactly.
And this vital documentation can't just sit on a shared drive gathering virtual dust, right?
No, absolutely not. The material emphasizes the need for robust version control to track changes, regular updates to reflect evolving systems and business needs, and, critically, accessibility during a disaster. This includes readily available offline copies in case your primary systems are completely inaccessible.
So you need to be able to get to it no matter what.
Exactly.
Okay, so we've got the plan documented. But when a crisis actually hits, it's not just about the technology, it's fundamentally about the people who are going to execute that recovery.
People are at the heart of it all.
The material then transitions to the importance of team structure and clearly defined responsibilities.
Absolutely. Clearly defined roles and responsibilities are critical in the high-pressure environment of a disaster recovery event.
Because when things are going wrong,
Yeah.
you don't want any confusion.
No, not at all. And the material outlines several key roles, starting with the DR coordinator. That's the person who takes overall command and oversees the entire recovery effort.
The general.
Exactly. Then you have specialized technical recovery teams, each responsible for recovering specific technology domains. Like you'll have teams for servers, networks, databases, individual applications.
So very specific areas of expertise.
Absolutely. Then there's the communications lead. That person is responsible for managing all internal and external communications, ensuring everyone's kept informed about the situation and the progress of the recovery.
Keeping everyone in the loop.
Exactly. Then there's the compliance officer, who plays a crucial role in ensuring that all recovery activities adhere to relevant regulatory requirements.
Dotting the I's and crossing the T's.
Exactly. And lastly, you have the executive sponsor. That person provides the necessary high-level support, authority for critical decisions, and allocation of resources.
So they're clearing the way for the team to do their job.
Absolutely.
Sounds very much like a well-organized incident response team.
Mm-hmm.
And the material also highlights the importance of having clear primary and backup assignments for each role.
You need redundancy built into the team itself.
And of course, ensuring everyone receives proper training. You don't want someone trying to figure out their responsibilities for the first time during a real crisis.
Absolutely not.
Now, a final crucial point the material makes is that disaster recovery planning is not a one-time project. You don't just check it off your list and forget about it.
You can never really relax, can you?
It's an ongoing, iterative process of continuous improvement.
Always evolving.
And that makes perfect sense. Technology landscapes and business needs are constantly changing, so the recovery plan needs to adapt along with them. So how does this continuous improvement cycle typically work?
Well, the material highlights a few key aspects. Post-incident reviews conducted not only after actual disasters, but also after drills or even significant near misses,
So learning from every experience,
are crucial for identifying what worked well, what didn't, and what needs to be improved.
taking notes.
Exactly. Regular reviews of the entire disaster recovery plan should be scheduled, ideally triggered by any significant changes to applications, infrastructure, or business requirements.
Staying up to date.
And tracking key metrics related to recovery performance, things like recovery times, data loss, that helps you identify areas where you might be consistently falling short of your objectives.
Measuring the success.
And it's also important to learn from industry incidents.
Seeing what's happened to others.
Exactly. What challenges have other organizations faced, and what best practices have emerged. And of course, regular refresher training for all team members ensures everyone stays up to speed on the latest procedures and their specific responsibilities.
So it's a continuous loop. You plan, you test, you learn from the result, you refine the plan, and then you do it all again.
It's a never-ending cycle.
Well, this has been an incredibly comprehensive exploration of everything that goes into designing a robust disaster recovery plan for critical applications. We've covered the entire spectrum, from the initial risk assessment to setting those clear recovery objectives, architecting the recovery environment, safeguarding the data, ensuring network readiness, leveraging the power of automation, the absolute necessity of rigorous testing, comprehensive documentation, defining clear roles and responsibilities, and of course, that all-important continuous improvement process.
We've covered a lot of ground.
We have, and it's clear that this is a deeply multifaceted and dynamic undertaking. But it's absolutely fundamental to the long-term resilience and survival of any organization that relies on those critical applications in today's world.
It's the foundation of everything.
So considering all these intricate layers of planning, preparation, and continuous refinement, what single element do you think is most often overlooked?
Ooh, that's a tough one.
Yeah, it is a tough one. And what could be the most significant consequence of that oversight in a real disaster? It's definitely something to ponder even after this deep dive is over.
Food for thought.
Absolutely.